This is the second video taking a closer look at centripetal acceleration. Just to recap, we established that the velocity vector was tangential to the radius of the position vector, and we found that the acceleration which is a function of t, is directed inwards towards the origin of our frame of reference. So this is a function of t and it's a vector. So let's define some notation. So this is commonly used in geometry as triangle. In physics and maths, in certain contexts, it's referred to as change. So I think that's all the notation we need to consider. Maybe put down S, which is displacement, and hence change in S with respect to t is our velocity. It's a function of time. I think we can probably put change in theta with respect to time is the angular momentum, angular velocity, sorry. And we can define S as a vector as some scalar multiplied by x and another scalar multiplied by y. And of course we're taking this as positive. So everything occurring in this direction is positive. Everything occurring in this direction is negative. So you can guess the value of the coefficient of our centripetal acceleration. Okay, so let's get rid of this. And I'm going to so let's do this is change in S. So we're going to start from position 1 and we're going to go to position 2, and the change in position or the change in displacement is going to give us a triangle. So we've got radius, radius, and then we've got change in displacement. So as we've already established, there is a velocity 1 here and a velocity 2 here, which is tangential to the radius. And we can draw our starting from this position and just go there. So we get velocity 2, velocity 1, got our theta, and this is change in velocity, which is the change in velocity, this is a function of time, is acceleration. Okay, so I hope you can see that I'm using this in the context of triangle. That triangle, let's call this x1, x2, and x3, is similar excuse me, to x1 dash, x3 dash, and x2 dash. So we can write triangle x1, x2, x3 is similar to triangle x1 dash, x2 dash, and x3 dash. So using ratios, we can say that the change in S divided by R must be equal to the change in V over V, because these are equal in magnitude, but because they are vectors, they're not equal in their natural form. So if we take the magnitude, they would be the same, but because velocity is a vector quantity, it changes when it's undergoing circular motion, it changes direction. So we know that the change in position, the change in displacement, is equal to V. So we've got our R as the denominator. The change in velocity is acceleration over V. We can multiply both sides by V. Cancels, and we're left with A equals velocity. Now we've already established that the acceleration is directed inwards. And since it's going in this direction, that gives it a negative, and that is called the centripetal acceleration, which is directed inwards towards the center of the circle. There's actually three types of acceleration. There's the centripetal, there is the angular acceleration, and there is the tangential acceleration. And we'll look more closely at those in the next video.